part one video for Integrated 2. I would say if you're doing this, I would definitely encourage you to watch the introduction video first, where I show you how to do angle bisectors and how to do perpendicular bisectors, because I'm just going to sort of assume that you know how to do that to make this go more quickly. All right, so the thing is, we're going to be working off of this construction graphic organizer, and I'm going to be using this website, mathpad.co.uk, for the constructions. So I'll just sort of read the question here and then bounce over here and do it. So the first thing, it says construct an equilateral triangle ABC, and then we're going to construct a median AM. And a median is just a line from the middle of one side of a triangle to the opposite vertex. So, but first we need to get the equilateral triangle. So we're going to go here. I can't remember exactly how to use this tool, so let me see what I can come up with. So we get something that looks like that. So I have this length here. So now what happens is I'm just going to make this arc. And what I know here is that any line on this arc is going to have the exact same length. So I can go ahead and do the same thing over from this side and use that same logic. And now what you'll notice is that any line from here is the same as any line from here. But hey, look, at this point, they're both going to be exactly the same. And that's going to be important because I know that this line is the same. I go ahead and get my little pencil tool here. Where is it? I know there's like oh, there we go. Okay. So I know that this line has this distance. Well, this line has to be the same because I hit that arc. Well, this line also has to be the same because it has the same arc. So there's my equilateral triangle. I know that these are all the same. And now what I need is the median. So I'm just going to get the middle of this side right here. And in order to get the middle of this side, I just need to pick something that is a little bit more than half of the distance from the same. So I'll make an arc over here. And this is going to get a little bit messy, but that's okay. And I'll make an arc over here as well. This thing gets real kind of janky on me. So I guess, well, what the heck, it's not going to hurt anything. I'll just make the whole arc. I'll go here and I'll make that whole arc. And what you can see is that I have perpendicularly bisected this side when I connect this. And again, it's important that you know what a perpendicular bisector is and how to do it. So I've cut the side in half at this point right here. And now what I need to do in order to construct this median, and I don't know, can I change colors on some of this stuff? Maybe, I guess I'll construct that median. I didn't realize I could change the colors, so I'll be doing that more often in the next stuff. But I constructed the triangle here, equilateral triangle, and then from there I was able to go ahead and do the perpendicular bisector of this side to get that point right there. I got the whole perpendicular bisector, but I didn't need the whole thing. I just needed that point. And then from there I can take that point and extend it to the opposite vertex, and this is going to be known as the median. Again, it goes from the middle of one side to the opposite vertex, so I have the median. Now we will go to 8-1b, and we're given just a triangle, so I'm going to go back over and just use a triangle. It doesn't have to be the exact same size, and we're going to construct an altitude. And an altitude goes from the vertex to the other side and forms a 90-degree angle. So what I'm really looking for here is I need a 90-degree angle here, a 90-degree angle here, and a 90-degree angle here. So actually, I'm only going to do one. So first of all, let me go ahead and make my triangle. And again, this is just a random triangle. It doesn't have to be anything in particular. And what I'm going to do is I'm going to go ahead and I'm going to make my altitude going from this vertex down. And again, what I need is a perpendicular bisector. So I'll go ahead, I'll go over here, and I will And again, I'll begin exploring changing my colors here to see if this lets me. I need to make an arc that will hit this side twice. And you can see I have done that. So now this point right here and this point right here are going to be important, because basically what I'm saying using congruent triangles is I want to cut this in half. If I cut this point in half and this point in half, what I'm going to get is the point in the middle, and that will give me the altitude. So I guess I'll experiment with changing colors again, and I'm going to go down here and I'm going to get the perpendicular bisector of these 2 points. So I'll just sort of make an arc here, and I'll move this across, and I'll do the same thing. I'll make the same arc, and now I know that this point right here, this point right here is a really important point for me. I don't know if there's a way I can I just make a point here? I don't know. So this point is a big deal, because if I go straight from this point to this point, I'm going to end up with the altitude. So I will make the altitude in black again. So here we go. This line from this vertex to right here is an altitude, and I know that I have a 90-degree angle there. All right, so moving along, we want to construct the angle bisector of P, and I've already shown you how to do this in another video, so I'm not going to spend too much time on this, but I'll go ahead and clear here again. I just need to start with a triangle. Doesn't need to have anything, although I'll make it similar. This was a convex triangle, so I will make it convex. And let's just go ahead and bisect this angle right here. So I'm going to go ahead. Again, I will go with the different colors. I think that seemed to help a little bit. I'll lock in my arc there, and I'll go ahead and make an arc here. And then I'll go here, and I'll make an arc. And I'll go here, and I'll make an arc. And if it seems like I'm going quickly on this one, I am. It's because, again, I've already done this in a previous video, so I don't want to spend a lot of time on the angle bisector. But again, it works because I know I'm using congruent triangles. So I have congruent triangles, and CPCTC lets me know that this angle is the same as this angle. So I have bisected that angle. And the last thing I'm going to do is make an isosceles right triangle using this line segment here. So I'll go over here. Again, I want an isosceles right triangle. So I'll just start by saying, hey, I'm going to make an isosceles right triangle that goes like this. So it has to be this length and sort of go up. So what I'll do, first thing I'll do is I need an arc that is exactly the same. There we go. Now I have this arc, and again, I'll change colors, and we will make this arc go all the way around. So a couple of things are going on here. First of all, I know that any line I draw up will be the same as this length here. So I know that like this length is the same. So I'm going to just go ahead and extend this line here. So if I go all the way through here to the end, through those points, you can see that this length is the same as this length. So that's important. Now what I can do is just use this point over here and this point over here and make an angle bisector. And then when I go up, a perpendicular bisector, I'm sorry. So if I perpendicularly bisect from this point to this point, I know this will be the middle. It'll cut it as a 90-degree angle, and I know once I hit this arc, I'll have my triangle. So let's go ahead, change colors again, and let's go ahead and perpendicularly bisect this thing. It needs to be a little bit more than halfway, so I'm going to make this thing a little bit bigger. And man, I'll tell you, I really like this tool, but I struggle with sort of going around in a circle sometimes. Okay, so now what we have here is I know that if I connect these points, it should go right through that middle. So I'll do that. I'll change my color back to black since it's going to be part of my triangle. And I'm going to extend it all the way up to the next arc. Is it going to let me? There we go. Actually, it wouldn't let me there. Huh. I guess I'm going to have to sort of freehand this one. Normally, I could just use a ruler and draw it straight up, but I need to hit that red arc. That's what's important, is that I hit that red arc. Because I know that this length and this length are the exact same, and I know that this is a 90-degree angle. And now what I can do is just connect these points here, and I have my triangle. And again, for whatever reason, this isn't just let me grab some like random point in. I'm not sure if it's like a pixel problem or what, but I definitely am having a bit of an issue with that. But bottom line is, there we go. There's my isosceles right triangle. That does it for part 1 of this video. Again, I know I went quickly, but I know there's a lot going on with this video, and you can kind of go through and look at CPCTC, and you can look at triangle congruence, side angle side, 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 etc. And you can understand why these things have to work the way they work. Again, just make sure you realize that these arcs allow me to get equal side length.